Hi everyone, in this video I will be discussing about the parabola. This is the second part of our topic on conic sections. So by definition, a parabola, it is the set of all points in a plane that are equidistant from a fixed point and a fixed line. So take note of these: fixed point and a fixed line. So later on, we will be talking about the fixed point and the fixed line and all other parts of our parabola, because our target for this video, or my target for this video, is for you to be familiar with the different parts of the parabola and also different standard equations and orientations when we will be talking about graphs later on. So I have here an illustration of a parabola, and this parabola is opening upwards. So its opening is upwards. And I think you're familiar already with the concept of parabolas, since during your grade 9, you have already discussed about quadratic equations. And when you were talking about quadratic equations, there were two orientations. So you had parabolas that were opening upward, and there were parabolas opening or going downward. But for conic sections for grade 11 pre-calculus, we now have four orientations, which I will be discussing later on. But just to give you an idea, for parabolas in the conic sections, aside from it opening upwards and downwards, there are parabolas that opens sideways. So there are parabolas that opens to the left and opens to the right. Okay, let me just erase this one first. So let's talk about the graph of the parabola and its certain parts. The first one, this certain point, that is called our focus. And from the definition earlier, the focus is our fixed point. Take note of that. Let me just write it clearly. Wait. So again, that is the focus. Okay, so again, the focus is the fixed point. Next, this line below, this is our fixed line, and we call this one as the directrix. So that's our directrix. Again, fixed point is called the focus, the fixed line is called the directrix. Next, this point here, that is called the vertex. If you can still remember, the vertex is either the lowest or the highest point of a parabola. It is the lowest point if your parabola is opening upwards. But if your parabola is opening downwards, the vertex is the highest point of the graph. Now for this graph right here, our vertex is currently at the origin, and the coordinates of the origin, as we all know, is at 0, 0. But if ever our parabola, let's say here in quadrant 3, let's just take that as an example, the coordinates of the vertex will not be anymore 0, 0. It will be two certain points, h, k. Okay, so let me just erase this one. By the way, take note, the distance from the vertex going to the focus and the vertex going to the directrix are equal. So this distance right here and the distance right there should be equal, or In terms of distance, it's called equidistant, equal in distance. Okay. Next, we have what we call as our axis of symmetry. So the axis of symmetry is a certain line. So it's a line. From the word symmetry, it divides our parabola into two equal parts. So it will look like a mirror image of the other side. So in this case, since our parabola is at the origin, or the vertex is at the origin, it so happens that the axis of symmetry, let me just write that down, axis of symmetry. So it so happens that our axis of symmetry is the y-axis. So if in the case that our parabola is here in this certain quadrant, in quadrant 3, our axis of symmetry, our axis of symmetry, wait, let me just draw that again. So if our parabola is located here, our axis of symmetry will be there. The axis of symmetry, it passes through the vertex. Also, the axis of symmetry is perpendicular to the directrix. Perpendicular meaning it will create a 90-degree angle. Okay? Next, we have what we call as the latus rectum. So the latus rectum, it is a certain chord or a line that connects, or a line segment that connects two endpoints of the parabola, and also it passes through the focus. Again, latus rectum is a line segment that connects two endpoints of the parabola, and it should pass through the focus. So those are important parts of the parabola. The axis of symmetry, it divides the parabola into two equal parts. The focus, that's the fixed point. The vertex is the lowest or the highest point of the parabola. The directrix, that is the fixed line. So next, we will proceed with different equations of the parabola. Now let's proceed to the equations of the parabola. So this is the summarized properties of graphs of our parabola. So again, we have four different orientations: upward, downward, to the right, and to the left. So we have parabolas opening upward, parabolas opening downward, parabolas opening to the right, and also to the left. Okay. We have equations whose vertex, or equations or graphs of parabolas that are located on the vertex. We also have graphs or equations wherein the vertex is not at the origin and is at a certain point h. Okay. So for graphs at the vertex, we have the following: x squared equals 4cy if it's opening upward. If it's opening downward, it's x squared equals negative 4cy. If it's opening to the right, that's y squared equals 4cx. If it's opening to the left, that's y squared equals negative 4cx. For equations or graphs whose vertex is not at the origin, so we have quantity of x minus h squared minus 4c times the quantity of y minus k for graphs opening upward. If the graph is opening downward, it's quantity of x minus h squared equals negative 4c times the quantity of y minus k. I think you're already familiar with HK since we've already discussed the concepts about circles. So HK, these are the coordinates of the vertex. So that's the x coordinate, that's the y coordinate. Next, we have the equation if the vertex is not at the origin and it's opening to the right. So quantity of y minus k squared equals 4c times the quantity of x minus h. And if it's opening to the left, it's the quantity of y minus k squared equals negative 4c times the quantity of x minus h. We can actually group the equations into two. So if you notice, if the exponent 2 is on the variable x, we can say or we can conclude that the equation or the graph of the parabola is either opening upwards or downwards. If the exponent 2 can be found on the variable y, as you can see here, we can conclude that the equation or the graph is opening to the right or opening to the left. So let's talk about the first group. So if C here, this part, if C is greater than 0, meaning 1, 2, 3, 4, 5, and so on, the parabola is opening upward. If C is less than 0, meaning negative 1, negative 2, negative 3, and so on, here, if it's negative, the parabola is opening downwards. Same here, that's positive, so it's opening upwards. That's negative, so it's opening downwards. For the second group, if C is greater than 0, here, it means that the parabola is opening to the right. If C now is less than 0, the parabola is opening to the left. So take note of those. Again, if the exponent 2 is on the x variable, it's either opening upwards or downwards. It's upward if C is greater than 0. If it's less than 0, then it's opening downwards. If the exponent 2 is on the y variable, it either opens to the left or to the right. And if C is greater than 0, it opens to the right. If C is less than 0, it opens to the left. By the way, if you have questions, if you have any clarifications, feel free to comment or type your questions in the comment box below. You can also send it to our group chat so that I will be able to entertain and answer your questions. At this point, let's try some examples so that you will be able to apply what you have learned earlier, and also so that you will know how to graph parabolas given their equation. But before we do that, before we proceed, take note, by the way, that for C, that is the length of the latus rectum, and the C, that is the distance between the vertex and the focus. Also, it's the same with the vertex and the directrix, since I have mentioned earlier that the distance from the vertex going to the focus and the vertex going to the directrix are equal. So let's take a look at this equation. That's y squared equals 16x. So if you're not yet familiar, we can go back to the summary of the equations of the parabola so that you will have an idea as to what the opening of the graph will be. So the given y squared equals 16x, it somehow looks like this, right? Y squared equals 4cx. So based on that, we can say that the parabola is at the vertex. So the origin, the vertex is at the origin 0, 0, and it opens to the right. So let's go back. Therefore, we can say that the vertex is at 0, 0, or it's at the origin. Also, it opens to the right since C or 4C is positive. C is positive. So, knowing the vertex, let me just draw the Cartesian plane. So let's say this is the origin. One, two, three, four, five, six, 7, 8, 9. So again, we already know that the vertex is at 0, 0, meaning it's here on the origin. Next, let's determine where our focus is located. So the focus is denoted by 4C. So that's 4C equals 16. Why? Because the length of the latus rectum is denoted by 4C. And since the latus rectum passes through the focus, so we have 4C equals 16, and we know that that is our 4C. So dividing both sides by 4, we will know that C is equal to 4. So how will we utilize or use 4 in order to determine our focus? So from the origin, since we know that our parabola or our graph opens to the right, so we need to count 4 units going to the right. So that's 1, 2, 3, 4, 5. Therefore, our focus is located at that certain point, and that point is at 4, 0. Therefore, the focus is at 4, 0. Next, let's try to determine the equation for the directrix. So since the distance going to the focus and the distance going to the directrix are the same, so we simply need to count 4 units to the left. So that's 1, 2, 3, 4. So let's draw the directrix. And since the directrix passes through the x-axis and it's on the left side, so which means negative, therefore the equation is x equals -4. Why negative? Because it's on the left side of the y-axis. The right side are positive integers, the left side are negative integers. So we already know our the vertex, the focus, and the directrix. Next, we need to determine the latus rectum, the endpoints of the latus rectum, so that we'll be able to draw our graph. So since we know that the length of the latus rectum is 4C, so the whole latus rectum is 4C. Therefore, for one side, it's 2C. For the other side, it's also 2C, right? So if we divide this equation by 2, we will have 2c is equal to 8, right? So therefore again, c is 4. So from the focus, we need to count 4 units upwards. Sorry. No, not 4. It's 8. 8 units upward, 8 units downward, because the whole latus rectum is equal to 16. So that's 1, 2, 3, 4, 5, 6, 7, 8 here. Then 8 units downwards, that's 1, 2, 3, 4, 5, 6, 7, 8. So again, let me just make it clear. The length of the latus rectum is 4c, and 4c is equal to 16. So therefore, from the vertex going here, so that's 4, and going upwards, that's 8, because 16 divided by 2, that's 8, and going downwards, it should also be 8. So now, we are able to sketch the graph of our parabola. Okay? Let me give another example. For example number 2, we have x squared equals negative 4y. Again, if you're not yet very familiar with the orientation of the graph, you can just go back to the summary. So take note, that's x squared equals negative 4y. So if we take a look at our summary, the equation looks like this. Meaning, the origin is at, the vertex is at the origin 0, 0, and the graph is opening downwards since 4c is negative, or c is negative. So we know that the vertex is still at 0, 0. So let me draw one, two, three, 1, 2, 3, 1, 2, 3, 4. So the vertex is located at the origin 0, 0. Next, let's determine the focus. Again, we have the equation 4c equals, it should be negative 4. Our 4c is negative 4. C is equal to negative 1 because we can divide both sides by 4. 4 divided by 4 is 1. Negative 4 divided by 4 is negative 1. And since our graph is opening downwards, since C is negative, so from the origin, we count one step downwards, and that's our focus. And our focus, the coordinates are 0, negative 1. For the directrix, since the graph is opening downwards, the directrix should be above the vertex. So, since it's negative 1, by the way, since we're talking about distance, this should be the absolute value of negative 1, which is 1. So 1 unit downwards, 1 unit upwards. So therefore, that is our directrix. Directrix. Again, always remember the distance from the vertex to the focus and to the directrix are the same. So if you move 1 unit downward, you also move 1 unit upwards. Since the directrix is passing through the y-axis, so that's y equals, the coordinate there is 1. It's y equals 1. So we already know our vertex, focus, and the directrix. Now let's determine the latus rectum in order to know the endpoints of our parabola. So since 4c is equal to negative 4, if we divide that one by 2, we will have 2c is equal to negative 2. Again, since we're talking about distance, that should be the absolute value. So from the focus, we move 2 units to the right and 2 units to the left. So that's 1, 2. To the left, that's 1, 2. So if we draw our parabola, it will look like this. In my next video, I will be giving more examples so that we will be able to practice graphing parabolas given their equation. For your attendance, kindly comment down your name and your strand, which is STEM, and your grade level 11. Again, if you have any questions, feel free to comment down below so that I will be able to answer and entertain your questions. That's all for this video. Thank you so much, guys. You take care always. Bye-bye for now.